All right, we're going to take a look at the rest of section 4.2. We've seen all the theory presented in the section. We're just going to continue to work additional homework type problems. Let's get warmed back up with number 60. The instructions say simplify, which in addition to everything simplify already means we now know that a simplified answer cannot have negative exponents. The only thing I need to do here is deal with that negative exponent. These are not like bases. There are no parentheses to drop. And that negative in the exponent indicates a reciprocal. It indicates that this x belongs on the other side of the fraction bar. This fraction bar, we know this sits over 1. Y to the 4th is going to stay where he is in the numerator. X to the negative 8 in the top becomes x to the positive 8 in the bottom. And that's all we're after there. Number 64. A similar problem. There are no like bases. There are no parentheses. All we need to do is deal with our negative exponents. And so, that 9 in the bottom is going to stay right where he is. P to the negative 5 in the top becomes P to the positive 5 in the bottom. Q to the negative 4 in that numerator is Q to the positive 4 in the denominator. And drag this r to the negative 3 across the fraction bar. R to the negative 3 in the bottom becomes r to the positive 3 in the top. And that's all we need to do there. We're going to crank it up a little now as we head on to the next little bank of problems. Actually, no. Let's do number 66 before we head to that next bank of problems. And then we'll crank it up a little bit. But number 66 first. I want to think about this in terms of a companion problem. I want you to consider the problem w to the negative 8 over w to the negative 9. That w to the negative 8 in the top becomes w to the positive 8 in the bottom. W to the negative 9 in the bottom becomes w to the positive 9 in the top. And we have a quotient of like bases. So we can subtract those exponents. In other words, when I'm done canceling, how many are left and where? Well, there are 9 w's in the top, 8 w's in the bottom. That leaves one factor of w in the numerator. It would be over 1, and of course we don't write over 1. That's exactly what we're doing here in number 66. Please remember, you cannot distribute these powers over addition or subtraction. Again, I consider that an unforgivable mistake. So don't try to bring these powers in. Although, if I were making a multiple choice answer for this problem that would be wrong, I would say, well, what if a student does this? Then some of them are going to remember that separate terms have their own fraction bars. And so each of those terms is going to be flipped with respect to its own fraction bar. Some of them not only will make the unforgivable mistake that I've done here, but will also then forget that separate terms have separate fraction bars and end up with So right there, I already have 2 wrong answers for my multiple choice. don't do it. This is exactly like my W problem. I have some base raised to the negative 8 power in the top. That becomes that whole base raised to the positive 8 in the bottom. I have this whole base raised to the negative 9 in the bottom. That becomes this whole base raised to the positive 9 in the top. And this, just like before, is a quotient of like bases. I have 9 of these things in the top. I have 8 of these things in the bottom. When I'm done canceling, how many will be left and where? If there's 9 in the top, 8 in the bottom, when I'm done canceling, that will leave one factor of x plus y in the top. So it'd be over 1. We don't write over 1. And since it's only to the first power, and we don't write that first power, I don't need the parentheses anymore. It is very important to be able to identify what is the base. And you see that this problem works out exactly like its companion problem here in W. Now let's move to this next bank of homework problems, and let's grab number 72. You may recall that I said when it comes to these types of problems, there are often many different ways to work the problems. That is certainly the case here. There are several ways to work this one problem. I'm going to show you a couple of them. One way to work this problem, although I don't think most of us will do this. One way to work this problem is to say, you know, all I have here is a product of like bases. All I have to do is add these exponents. And so, at least in my head, I'm going to add the exponents. This will be y to the negative 8 plus 5 plus negative 2, which is y to the negative 5. And I have a final answer without a negative exponent. I reciprocate that. This y to the negative 5 sits in its own numerator. It becomes y to the positive 5 in its denominator, leaving nothing in the numerator, the multiplicative nothing, that residual factor of 1. On the other hand, I think many more of us would look at the problem this way. We would say, okay, this is one term. It's all multiplication, so it shares one big fraction bar. That y to the 5th can stay right where he is in the numerator of the problem. Y to the negative 8 in its own numerator becomes y to the positive 8 in this denominator. Y to the negative 2 in the top becomes y to the positive 2 in the bottom. Remember, this whole thing can be thought of as to sit over 1. So it is just one big numerator. In this denominator, I have a product of like bases. Product of like bases, you add the exponents. Y to the 8 plus 2. There's a total of 10 factors of y in that denominator. And then look at this as a quotient of like bases. Now, strictly speaking, what that means is that this is going to give us, and this is not how I do things, but strictly speaking, that means it's going to be y to the 5 minus 10, or y to the negative 5, which brings me in right back here. I'd get the right answer. Quotient of like bases, subtract the exponents. The exponent from the numerator minus the exponent from the denominator. In this case, that gives me y to the negative 5, which I would then write as 1 over y to the positive 5. But here's how I prefer to think. This is why I've explained this to you using this idea of canceling. I like to look and say, well, I've got 5 y's in the top. I've got 10 y's in the bottom. How many are left and where when I'm done canceling? And we go back to this idea. We've got 5 y's in the top, 10 y's in the bottom. And when I'm done canceling pairs of y's top and bottom, what's that leave me with? 5 factors of y in this denominator. It leaves nothing behind in the numerator because they would all be canceled out. And so I get 1 over y to the 5th. Couple different ways to look at and attack this particular problem. Again, my favorite way of dealing with a quotient of like bases is to always ask, how many are left and where? Number 74. Several ways to do number 74. But this one I'm going to work just the way I consider to be the slickest. The first thing I'm going to do is deal with my negative exponents. I could start this problem by distributing these powers in to the parentheses in on those factors. But I'm going to start by dealing with the negative exponents. This 2y, and that whole thing is the base, to the negative 3 in the top becomes this whole 2y to the positive 3 in the bottom. Likewise, this base to the negative in the bottom becomes this base to the positive in the top. Now, I don't have any negative exponents to deal with. I like that. Now I will distribute and bring these powers in. As I do that, I will get 5 to the 4th, y to the 4th, over 2 cubed, y cubed. We have a few more things to do before we're simplified. We have 5 raised to the 4th power. Do you remember from last time? We've seen that a couple times already. That happens to be 625. 2 to the 3rd is 8. And then we have this quotient of like bases. We've got some y's in the top, some y's in the bottom. We have 4 factors of y in the top, 3 factors of y in the bottom. How many are left and where when I'm done canceling? That's the way I like to deal with the quotient rule. When I'm done canceling, I will be left with a single factor of y in this numerator. And that's just my quotient rule. 4 minus 3 is positive 1. Y to the positive first. I still like to say how many are left and where. Number 82. Now, in the last problem, I dealt with my negative exponents first. And I mentioned I could have started by distributing. But I worked it the way I consider to be the slickest. In this problem, in number 82, I could move this whole base in the top to the negative 4 to be that whole base in the bottom to the positive 4. And I could move this whole thing to the top to the positive 5. The same way I did the last problem. But I don't think that's the best approach this time. And the reason is, I've got negative powers inside and out of my parentheses. I think I'd like to drop the parentheses this time. It's not the only way to do the problem. There are at least 16 different ways to work this one problem. I'm going to show you what I think is the slickest. Because there are negative powers inside and outside the parentheses, I would like to drop the parentheses and see which ones are going to remain negative. That is, which of these bases will actually need moved. That avoids moving them and then having to move them back after I distribute. So I'll distribute this power of negative 4 to each of the 3 factors here in the top. I'll distribute this negative 5 to each of the 3 factors there in the bottom. A squared to the negative 4. That's a power to a power. Power to a power you multiply. A to the negative 8. Likewise, B to the negative 12 and C to the negative 16. Now distribute this power of negative 5 in the bottom. A to the negative 2 to the negative 5. That's a power to a power. You multiply. A to the negative 2 times negative 5 is positive 10. Likewise, B to the positive 15 and C to the positive 20. There are several different ways to proceed from this step. But here's what I think most of us will do. We're going to look and we're going to say, all those guys in the bottom are going to stay in the bottom because they have positive exponents. And all the guys in the top are going to have to move because they all have negative exponents. A to the negative 8 in the top becomes A to the positive 8 in the bottom. B to the negative 12 in the top, B to the positive 12 in the bottom. Same for the C. C to the positive 16 as we move it to the denominator. That leaves nothing behind in the numerator, the multiplicative nothing, that residual factor of 1. And then to finish this up, I see I have products of like bases here in the denominator. A to the 10th times A to the 8th, product of like bases, add the exponents. How many factors of A do I have altogether down there? A to the 18th. B to the 15 times B to the 12, add the exponents. B to the 27th and C to the 36th. There's nothing else I can do, and so that's simplified. Let's have a go at number 84. There are at least 16 different ways to work this one problem. Let me show you a few ways to start the problem, and then I'll tell you which is my favorite way. One thing I could do is I could interpret this negative power on this fraction. And I could say a fraction to a negative is the same as its reciprocal to the positive. Turn the fraction upside down to change the sign on that power outside the parentheses. That would be one way to start the problem. Another way to start the problem, I could deal with these negative exponents inside. And I could say, well, just looking inside, that W is going to stay where it is. Z to the negative 5 in the top becomes Z to the positive 5 in the bottom. W to the negative 3 in the bottom becomes W to the positive 3 in the top. And that Z to the positive first stays where he is. That did nothing to my negative 2, my power on the outside. All I did was move those two negative exponents across the fraction bar. Another way to start this problem would be to distribute. And we've learned that to distribute over a fraction is to distribute to every factor in that fraction, the 2 in the top and the 2 in the bottom. That's the way I want to do the problem. Several ways to proceed from here if I started this way. Several ways to proceed from here if I started that way. But I think the best way to approach this problem, not the only way, but the way I like best, because there are negatives inside and outside the parentheses, I want to drop the parentheses and see who all is really negative. Which factors actually end up with a negative exponent. And so as I distribute this negative 2 in on the top of this fraction, I will get W to the negative 2, Z to the negative 5 to the negative 2, power to a power you multiply, Z to the positive 10. As I bring it in on the bottom, W to the negative 3 to the negative 2, that's W to the positive 6, and a z to the negative 2. I think this is the cleanest way to start this problem. Not the only way, and we could have worked at those other ways. We would still get the same answer so long as we don't break the rules. Now from this point, there are a few ways to keep going. But I think what I want to do is deal with my negative exponents now that they're all out running around free. And I know who is actually going to have a negative exponent. This w to the negative 2 in the top becomes w to the positive 2 in the bottom. Z to the positive 10 stays where he is in the top. W to the 6th stays where he is in the bottom. And z to the negative 2 in the bottom becomes z to the positive 2 in the top. To finish this off, I just deal with these products of like bases. In the top, z to the 10th times z to the 2nd. Product of like bases, you add the exponents. How many z's are in the top altogether? That's z to the 12th. And then here in the bottom, product of like bases, add the exponents, w to the 8th. Many, many different ways to go about working this problem. Many ways to proceed from almost each step. But if we follow the rules, no matter how we go about doing it, we should all end up with this same answer. I would encourage you every once in a while in these problems to mix it up a little. Work the problem 2 different ways. What's a couple different ways you could start this problem? And see if you can work it 2 or maybe even 3 different ways and get the same answer. That'll help you with your rules of exponents in general, and will give you more tools to work with, more approaches that you have at your disposal when it comes to working these problems. Number 86. Now, as I look at number 86, I will tell you this right now. There is absolutely no way that I'm going to consider distributing these powers into the parentheses. There's nothing wrong with it, but my goodness, what a mess that would make. This looks like that next to the last step in the problem that we just did. We've got a couple negative exponents running around. We've got a couple positive exponents running around. Let's just deal with our negative exponents. The base is 8x in all cases. Okay? This is the same as working this problem. Which is why I don't want to bring those powers in on the parentheses. How would you finish this one off? One way to do it is to say that a to the negative 8 in the top needs moved across the fraction bar, becomes a to the positive 8 in the bottom. A to the 9 stays where it is, a to the 13 remains in the bottom, and a to the negative 11 becomes a to the positive 11 in the top, and keep going. That's exactly what I'm going to do here. This base to the negative 8 in the top becomes this base to the positive 8 in the bottom. This base to the positive 9 stays in the top. This base to the positive 13 remains in the bottom. This base to the negative 11 in the bottom becomes this base, the whole 8x, to the positive 11 in the top. And I think we can finish this in one step. You can take 2 steps to do it if you want. Product of like bases in the top, product of like bases in the bottom. Let's do it with the a's. That would give me a to the 20th over a to the, add them up, 21st. And when I'm done canceling, how many are left and where? One factor of a survives in this denominator. We don't write to the first power. I think we could have done that without using this step. We could have said how many a's are in the top, how many a's are in the bottom. There's a total of 20 A's in the top, 21 in the bottom. How many are left and where? And that's how I would finish this problem. How many 8x's are there in the top of this expression? 9 plus 11, a total of 20 of them. There are 20 of these guys in the top. How many in the bottom? 8 plus 13, 21 in the bottom. If there's 20 of those in the top and 21 of them in the bottom, when you're done canceling, how many will survive and where? A single 8x will survive in the denominator, leaving a 1 behind in the numerator, that multiplicative nothing. I no longer need parentheses because raised to the first power is just itself. And there it is. Do you see why I would not even consider distributing those powers? If I think about it for a minute, that's just going to make a much, much messier problem. Let's finish up with one of the bigger ones, number 92. I would encourage you to pause the video and work this one out on your own and then compare answers. Let's look at it first. And let's think about how we might want to start this problem. There are at least 32 different ways to work this one problem. Some of them are nice and clean. Some of them are particularly messy. Some of them are just interesting. But what do you think we should do to get this problem started? I've got parentheses. I've got negatives inside. I've got negatives outside. I think the first step that I would do on this is distribute these powers so that I can drop the parentheses. Now, if you want to pause here and join me for the next step, go ahead and do that. Once we distribute those powers, this will look like m to the negative 12, n to the negative 2. Remember, power to a power, m to the 6 to the negative 2, multiply those powers. Times m squared cubed is m to the 6th as we multiply, and n to the negative 6th. And we did nothing with these guys in the bottom. Now, I'll give you another chance to pause the video after we think about what we want to do here. Several ways that we can deal with this, but I think what most of us will end up doing is dragging factors across the fraction bar. This m to the negative 12 can be pulled down to become m to the positive 12 in the bottom. Let me let you pause here and see what you get for your next step. So, we said one way to proceed from here is to consider our negative exponents as needing dragged across the fraction bar. M to the negative 12 in the top becomes m to the positive 12 in the bottom. N to the negative 2 in the top, drag him across to become n to the positive 2 in the bottom. M to the positive 6, he's going to stay right where he is in the top. N to the negative 6, let me write this over to the left. I'm not sure why I put it in the middle. N to the negative 6 in the top, drag him across. N to the positive 6 in the bottom. M to the negative 1 in the bottom. Take him to the top where he's m to the positive 1. We don't write a power of positive 1. And my n to the negative 2, take him across. He becomes n to the positive 2. Now we have all positive exponents. Nice. What do you want to do now? Well, one thing I could do is I could count up how many m's are in the top, how many are in the bottom, and how many are left and where. Let's do it that way. Finish this off with me. We have what? 7 M's in the top and 12 in the bottom. How many are left and where when you're done canceling? 7 in the top, 12 in the bottom leaves 5 factors of M in that denominator. Now my n's, I have 2 factors in the top and 8 factors of n in the bottom. How many are left and where? 6 factors of n in the bottom. You could also have said, look, I could cancel those, and that just leaves you an n to the 6th in the bottom. It's the same as subtracting, saying how many are left and where. That leaves me nothing in this numerator, nothing but that residual factor of 1, and there's my answer. So what do you think? Lots of practice, guys. Lots of practice. And so the assignment now is the balance of the homework as originally assigned on your handout. And I'll let you get to that.